Um, one other word that I think this illustrates the vast amount of parameters and things you have to deal with when you're trying to use these empirical methods. And, physical scientists might not have the background, the rigorous background that computer scientists have in some of these things, like when you're looking at probabilistic graphical methods or models. You look at Bayesian networks, it can be modeled by directed graphs or are modeled by directed graphs. Markov networks are modeled by non-directed graphs. That is studying data structures in the sophomore year of computer science major. Do we see that in physical sciences? I don't think we learned that, and it's a pretty trivial thing that is important in order to get to probabilistic graphical models, which are important in machine learning and inference scenarios. We would like to promote that type of thing, not by teaching data structures, but by having this exchange in an ongoing basis. And one of the ways we can do that is by participating with the AI Club, by having more events like this, when we have grad students expose their projects and what kind of strategies they're using. If we can, have something like that going, I think you do a great thing to promote machine learning sciences, because it's clear that we're going to need domain expertise, and we're going to need machine learning expertise combined to use this great tool. And our dean here, James, I think saw that early on and would like to have this Nexus become an ongoing experience for us, where we can get your participation and start exchanging these knowledges, so we can have local expertise on these, with collaborations with computer scientists, which are going to have soon today.
Can I say,
please?
You mentioned you wanted me to say a couple things.
Yes.
Before I wasn't here earlier, but so the goal with all of this is that I've gotten a sense that there are a lot of people in each of the departments in the school that are starting to sort of use various aspects of AI and machine learning in their research. But the connections, so there's sort of natural potential for collaboration within the school, but then also obviously we want to build connections with ICS and people across the quad there who bring in significant expertise. So the hope with this is we're sort of start getting some folks together with some interest in this area. But what we'd like to do is continue some kind of project over the year, where we can have a series of we're thinking seminars and get-togethers with people who have an interest in this area. And we're sort of thinking, we might just have coffees, seminars maybe once every other week or so, with sort of people doing interesting stuff on campus. And so the point of these seminars would not be to necessarily bring in experts from offsite, although we could do that, but really introduce ourselves to each other. Within about a year, the building across the quad is going to be up and populated. And the intention is at least a fair number of the folks from ICS who do AI and machine learning will be sitting right there. So literally, right, a football field away, physical sciences is going to be in close proximity to a lot of world-class expertise in machine learning and AI. And that's a huge win for our school, I think. And I think just getting a group together like this and to start learning from each other, understanding what the most important questions are, so that we can build those bridges. That's kind of the goal of this. We're kind of making it up as we go along. Nico's had a lot of great ideas getting this thing together. But if people want specific things, we can do that. If you'd like to have certain formats, just let me know and we can work together to put something together. We're going to be announcing a few opportunities for graduate fellowships in machine learning that will probably be starting in the winter. And so graduate students who are working on projects in this area will be encouraged to apply. And we just want to provide an infrastructure of support so that hopefully as people start then getting grant money, and become sort of a self-supporting enterprise. So I think of this as an experiment. Maybe it will be useful. I hope it will be. If not, we'll try something else. But that's the purpose. So please do let us know if you have ideas, anything you want to change or stuff you'd like to see, kinds of talks and interactions you'd like to see over the next year. You can let me know, you can let Domingos know, and we'll try to do that.
All right.
Can I make a suggestion?
Sure.
Right now?
Yeah.
More introductory stuff.
Yeah, okay.
That helps you when you before you actually start a machine learning approach.
Yeah.
So figure out, just like your question, figure out, okay, I want to use some magic machine learning, but which method should I use in my case?
Yeah, yeah.
And sort of what was discussed earlier, depend on what kind of data you have, how much data you have. So we need a decision tree on
Decision tree of which algorithms.
Oh my God.
Yeah, I think that's great. I mean, that's, you have some problem. I think it's generally true, right? There's a bunch of people in this field have problems they want to solve. For example, your question, they're trying to ask the question, what tool should I utilize to help me?
I mean, we all have limited time, and so we don't want to waste our time on a method that turns out, oh, in my case,
So
method,
optimal.
it's just going to be bogus because I need to apply it to all my data, say, and then just.
So maybe some of the seminar instances could be a workshop format where we go over the basics of machine learning.
Or maybe even we have people come in with 10-minute spiels on the problem that they're trying to solve, or like, this is my science, and we've got a bunch of experts in the audience who just immediately say, oh, I'd like to work with you on that. I've got an answer for you. And those kind of collaborations, I think, would be, I would hope, would be.
That would be very useful. Okay, well, you're out of your mind if you're trying to do this. You need the computation power of the entire world. This one can be solved much easier.
Indeed. We had a good discussion yesterday with Shane's project. People were scrutinizing his choices of, parameters, and I think it challenged him in good ways and illustrated how we should be doing this too. We would like to see what you guys are doing, projects are you using for your PhDs, and if you're using machine learning or thinking about using machine learning, come in, present what you have. Experts in the audience can give you some direction. And if we build a clearinghouse of expertise in a way, always have a core group of people that are pretty versatile with these tools that we can, maintain over the years. Because people graduate, they go somewhere else, and we lose that talent, but somebody else steps in, and having that momentum of expertise in machine learning, you eventually permeate the whole sciences, physical sciences, and might be a part of our, of our tool set at that point. Please.
So I have a really difficult task of trying to give an introduction, but I kind of wanted to make it useful. Maybe doing a specific theme, like how many people would like, doing like a call for people who have image data, how to deal with images versus people who have little to no data, but they know they want to use some kind of machine learning technique and maybe generate some models and then see how they fare. Or people that are specific to climate change that want to do kind of Earth system science air models or something like that. So that way, if I kind of, or if people who have machine learning knowledge, those that have domain knowledge, have similar backgrounds in terms of, okay, I can deal with a lot of data, or okay, I deal really well with images. I work with image processing, computer vision, and I see that your cloud cover images will have a good application for this technique that I've created. Having a workshop around that and then using the tools for that specific application might be worthwhile. So, okay, today's an image day, and we're going to do image analysis in computer vision using a neural net. So we're going to use Keras, and then just having that example kind of focus on just that might be something that people learn from.
Definitely, definitely, yeah. Like Casey, remember Casey Graff talking about how to, you know, the latest issues of finding the learning rate. I don't know, this was in a talk that we had after he finished his presentation. These things can be very, you know, these are latest things, latest controversies or strategies that people are dealing with out there that we can incorporate right away if we understand that. It's a big thing about finding the learning rate. It's kind of a alchemy type of thing, right? You go a little here, a little there, and you know, your computation is not enough to have that small learning rate, so you make it bigger, but you miss the point type of thing. How can we automate that thing? They are discussing this right now in forums I've been reading. We can participate in that too. This is a very valuable tool or set of tools for sciences. And the cloud companies are not going this direction. They have a brute force attack with neural networks, and that works well for them. And for some of us probably, right? With high energy physics and genomics, that works well too. But I think most of us, or most of physical scientists, will be limited by the data, and therefore feature engineering, neural network architecture, you know, strategies become much more critical, you know, at the onset. Anyhow, any other comments or questions? Thanks, James, for coming in and supporting the cause.
Hours, but I hope people find this useful. I just kind of pose a question, just to kind of like most of the students here. Like, why are you here? I wonder, is it because you're seeing machine learning being used in your fields and you want to get in on it? Is it because you're already using it, but you want to, you know, improve your techniques? Just because you wonder what the deal is? I mean, I just wonder, I'd like to get some sense of what people's feelings are among the graduate students.
We have time, we're kind of early. Why don't you go around and you address that, every one of us? How about that? Starting here.
Sure, so I don't do machine learning for my research, but I have taken the class and do some side projects with it. So I already know the basics. I was curious in what
Yeah, I work in math in my column. I was looking at actual real world applications and I see them in machine learning, but I don't actually understand what's happening with them.
I'm working on the videos like so that's when we data changes. So I didn't use much to find out.
So I'm working in theoretical chemistry, and in our field, there are many problems which are kind of restricted by the computer power. because if you just make physics-based models, simulating them becomes very hard. So recently, some groups in the world are trying to use machine learning problems. I do not use it myself, but I want to learn that I can also get in there. Yeah.
I just put up a project in my lab where I'm getting a lot of data, like computer experiment stuff, and I right now kind of like looking at all around that concept, and it just kind of seems right.
Creates large data sets that can benefit the machine. Use its small amount in my lab, and I've been trying to curate my grad students to do all.
Well, I'm going to probably have to help a lot of people figure out how to implement machine learning to address their problems that should actually help.
Okay, so I don't use machine learning. I do the next best thing. I talk to people that know how to use it. So I'm a physicist, and I have a problem with human processing. So I'm working with some people in the ICS department to address this problem. I want to understand machine learning a little bit more myself.
General interest in how people see machine learning or not deeply involved.
So I'm in this department, and my group is currently working on the science department. My graduate here in the department. So I don't necessarily do the machine learning part yet, but I want to learn more about it.
You have large data sets and machines are implementing machine learning techniques.
Yeah, I'm a theoretical chemist. I recently started to data, and I want to know what else. Yeah, I'm in plasma physics. I'm also in the machine learning and physical science program, and I'm in the maths program for the statistics techniques for Penson with using the burns of a fast ion population diffusion device. And I was introduced to machine learning there, along with the statistics. We do have active collaboration with statisticians, but I'm interested to learn more about machine learning.
I'm in condensed matter theory at this point, and I don't really use machine learning for machine learning, but I do just baby machine learning in my internship, and I just kind of want to learn a little bit more, see what there's going on there. I've exposed to machine learning in my work school, and I got interested in the math and how it can simulate physics. I started using it for different kinds of physics and energy materials.
I work with satellite motion color data and constantly trying to find how they can things like, light coming off of the surface of the water and what's actually in it. And a lot of papers have been coming up where researchers are using neural networks and machine learning techniques. And I have no idea how to do it. I feel like they're going to do my job.
So I make continental scale projections in Antarctica to the end of the century. And so it doesn't use machine learning, but it's a topic that really interests me. And I kind of like to find an avenue to apply it to my research. So that's why I just want to learn a little bit more about it.
So I'm an energy physicist and a cosmologist as well. And I think machine learning is kind of a future that is happening now. I've not been exposed to any specific problem in my research, but in the life in a good way, that is possible.
I'm here from UCI. I'm a meteorologist, and I never worked with a machine learning before, but I can imagine that the field is moving in that direction. I would like to learn how she uses it in research.
I'm a chemist. My group does a lot of electron microscopy. And I think in general, the electron microscopy field now is starting to get into machine learning. So we've started a few projects. And yeah, the field is just touching upon it, but there's not really a lot that's been done.
My research is in the mathematics of machine learning classification of deep neural networks.
So most of my work is just theoretical so far, and I would like to say what
I'm from the chemistry department. I'm in a collaborative project with Dr. Baldy, applying deep learning to atmospheric reactions.
I'm in my research doesn't but I'm curious to learn about it because I understand it's an important skill if you want to get a job outside of academia.
I'm also in the math department. My research has to do more with the theoretical aspects of machine learning, specifically for dimension reduction, but I kind of want to learn more about how you actually apply it.
I'm in the ECC department, and I see that machine learning is being applied not only in earth scientists, but also in all fields of engineering. So I think it's a real skill that in the future will be really useful for an engineer or for any kind of job.
You're next, Helen.
So I am not using machine learning in my work, but I definitely encounter it. So I'm the director of research development for the School of Physical Sciences. I basically work with faculty to develop their grants or help them identify grant opportunities that they can apply for. Over the past few years, I would say I've noticed a lot of interest. The federal agencies have expressed a lot of interest in machine learning, and so they've developed some grant programs and released a lot of solicitations to fund specifically like machine learning projects. So that would be through the NSF, NIH, DARPA, maybe also Department of Energy. So my purpose in being here today is to learn a little more about machine learning because I'm not familiar with the field, but I do anticipate encountering it when I work with faculty and maybe even the grad students here on potential research proposals. And I'm also really interested in learning about everyone's research areas because I can help facilitate building connections between potential collaborators on campus.
So you do encourage the research groups to come to you and discuss grants?
Yes, definitely. And if I, maybe if I see relevant opportunities, I could send that out to someone, or maybe there's a listserv or just a listserv of relevant of faculty participating in this Nexus. I mean, I could communicate that way. We could discuss that further.
Great. Make a note of it.
Yeah, I think one thing that we could take note of too is we're just sort of constructing a website for this whole endeavor now. We can think about what kinds of things we want on this website, just for like posting information, link to these videos, link to the talks, but also grant opportunities. We're sort of making this up as we go along, so I think that's a great idea.
I'm a postdoc in Jerry Group, so I primarily work on machine learning for like signal processing and then more getting into computer vision tasks using neural networks.
I'm a particle physicist, and machine learning is very topical, so I want to find out more about it. If possible, apply it to my research to make our methods more efficient.
I'm in astrophysics, but I started in electrical engineering a long time ago. I've had a long-standing interest in neural networks, even in the 80s. Neural networks are a thing. And so it's a personal interest, but also in astrophysics, big data is here. There's huge data sets out there, and I can see that machine learning is going to be a way to exploit. I don't yet have a good application, but I know it's going to be.
I'm a theoretical chemistry graduate student. I don't know computer science or anything really about machine learning, but I've seen it applied to solving issues like dynamic problems and different things on this.
So So I could say personally, so I'm an astrophysicist. My research is primarily theoretical and involves large numerical simulations. Over the last couple of years, I've had some students doing projects related to machine learning. And about a year ago, a student showed me something that he had discovered by analyzing our simulations with a deep neural network. And it was something that I didn't know already, even though I've been working on this kind of stuff for probably 15 years. And he showed me that as sort of a visceral reaction to me. He's like, holy shit, there's something to this. And so since then, I've sort of been paying a lot closer attention to these methods. And I've seen it in conferences in my field where people are starting to use these techniques in a lot of different areas in astrophysics. And it's always the younger people who are leading the way. And it's the one time in conferences where the senior people kind of shut up and the younger people start to talk and lead the discussion. And it seems to me that this is holding the future. And I don't know. So to me, it sort of seems to me like this is an advantage that I hope that we can give to some of our students by providing opportunities to learn more about these techniques, because I suspect that at least many of the most important advances in some of these fields are going to be driven by these approaches, and it's important for us to get in front of this.
Yeah, I'm a glaciologist using various kinds of satellite data, like images or some photon data. The reason, actually, one of the topics is that I need to detect or classify some feature of the glacier. And most of them has been done by manual, but in this day, the data kind of piling up so that human can catch up with that. So I think that this is the time we need to start automating the detection and segmentation problem. So we kind of started implementing, we kind of started using the machine learning stuff, and I think it's kind of working. But I think there's a lot of things we need to solve, like on data volume or something like that. And the reason that I'm attending this workshop is that there was a lot of application that's going to be introduced in this workshop, so that I can look at what kind of application, what type or what categories of problem can be solved using that technique, so that I can reference the information to what kind of problem can be solved in our
I'm studying theoretical chemistry. I don't know whether machine learning is that hard or not, but I would like to know that because at some point of time I would like to do some projects using machine learning just to know the fundamental skills.
And as I mentioned, it's very useful and part of the technology that it does as well. And also opens the door, I think, outside of academia. So I don't know where I'm going to get, and I kind of think that regardless of what decision or what direction I go, it will be useful skills I have.
These programming sound will be balanced very remotely, so I don't like direct reactions. And I would like to implement actually like machine learning networks to simulate reactions, chemical reactions for numbers. And at the same time, I'm tired of Fortran, so I want to. So that's another thing, and yeah.
So are you focusing on Python now as a language?
Yeah, I'm focusing on Python. I mean, like there are like a lot of functions very models. So one being will be like to implement like surrogate models to resolve like chemical reactions.
Well, I'm not part of physical sciences as an review and domain, so I'm actually a computer science student over in ICS, and I work in the computing department. So I help make the website incident.
And she's one of the students that won Data Fest this year in April. I want to give her
anomaly detection at video class with some Canadian news rugby data since unusually harsh collisions, and then predict the downtime time that they would need to recover so that the coach can cycle them back into the game at an optimal time. So it doesn't cycle them back too soon, and they get burned out versus, you know, cycling them too late and then missing opportunities to win. She actually that's all good. I was a speaker. Right now I am adjuncting at different schools. I teach mostly in the CS department, programming classes, Python, as well as introductory machine learning and data science courses. I am continuing the research that I started during my PhD on home automation and autonomous agents using primarily reinforcement learning, but I am really interested in other machine learning modalities, having been introduced to them as signal processing.
All right. Thanks for speaking about yourself. We have some people in the perimetry that didn't talk. Hi.
I'm Carl, so I was very ineffective.
All right.
My background actually work-wise is in IT systems administration. I want to learn class on things. It's interesting to learn about hardware resources. I work on smart city applications.
Professor Daniel Whiteson.
I'm Daniel. You'll be hearing from me in a few minutes on my research. Physics professor, I've always been interested in machine learning. Actually, every other person in my immediate family has a degree in machine learning. I'm the only physics outlier. And involved in the master's program here, try to teach physics people some machine learning and machine learning physics people some physics. And so very interested in working with people across the island, bringing awesome new hammers to our existing games.
All right. And Professor Whiteson is going to be on in 12 minutes or so. So we can take a break, stretch our legs.